Very good morning, dear students. So, in the last session, we have discussed the different characteristics of biomass, which are more important in the energy production view. Now, in this session, we will familiarize with the different routes for energy production from biomass. Okay, so this is the most important picture which will give us an overall view about different routes for energy production from biomass. So here you can see we have categorized the energy production routes into four, that is thermochemical conversion, biological conversion, chemical conversion, and finally physical conversion. So in this you can see thermochemical conversion, mainly we have combustion, gasification, pyrolysis and liquefaction. And biological conversion, we have mainly anaerobic digestion, and fermentation is another biological conversion. And chemical conversion, the most important one is transesterification. And we have also solvent extraction and hydrolysis. And physical conversion, we have the densification of biomass, that is the briquetting of biomass, and distillation, etc. So this is the broad classification of routes. And thermochemical conversion, you know that we are chemically converting this biomass into either a liquid or a gas or a mixture of liquid, solid and gas. And all of these are high temperature process. And on the other hand, biological conversion, we can say it's the help of microorganisms. We are converting either into biogas, ethanol, etc. And chemical conversion is purely by the chemical action with some reagents, like transesterification, which is the production of biodiesel process. And physical conversion, we are not producing any energy in that process, but we are simply converting our biomass into more useful form, like briquettes, etc. So this is very, very important. You have to understand this category of routes for energy production from biomass. And already we have seen that thermochemical conversion, we have mainly four categories. In that, these three are very, very important: combustion, gasification and pyrolysis. So already you might have heard all these, and some of you already have an idea about this. So what are the difference between these three? We must understand that. So first difference is the oxidizing agent to biomass ratio. So in most of the case, oxidizing agent will be air, or in some other case we can use pure oxygen also, and steam can be also used as an oxidizing agent, like in gasification. So the first classification is based on their oxidation ratio, that is the air fuel ratio we can say, or the oxidizing agent to biomass ratio. So what happens in combustion? Combustion, we know that the supply of oxidant is greater than the stoichiometric ratio. So you know stoichiometric ratio is the chemically correct air fuel ratio or oxidant ratio required for complete burning of that biomass or any fuel. So that we can determine using its molecular formula, which can be obtained from ultimate analysis and proximate analysis. So already we have studied that. So based on that chemical formula, we can obtain the stoichiometric ratio. And if the air supply or if the oxidant supply is more than this ratio, that is excess air or excess oxidant is supplied, that is known as combustion. But on the other hand, gasification, this will be less than stoichiometric ratio. Normally it will be some 0.2 to 0.4 times the stoichiometric ratio. And in pyrolysis, we can say it is almost completely absent. So that means pyrolysis is carried out in the absence of oxygen or air. So this difference you must understand. This is the basic difference between these three categories. So in combustion, we are providing excess air or excess oxygen and it is greater than stoichiometric ratio. In gasification, we are providing less than stoichiometric ratio, and in pyrolysis, we are providing almost zero oxidizing agent. And the typical temperature range, what will be the temperature range of this process? Combustion, we know that it's around some 800 degree to 1200 degree depending upon the reactor, biomass, etc. And gasification also, we have different types of gasifier, we will study it later. So its range is around some 800 degree to 1200 degree, and in some endrain flow gasifier, etc., we can go beyond this 1200 degree. But in pyrolysis, it is not that much high. You can see pyrolysis, the temperature range is only 350 degree to 600 degrees Celsius. So it's a comparatively low temperature process. And another major difference is in terms of products. So what are the products of combustion? Principal products. So combustion, our main product will be heat. So after combustion, we can use the heat coming from the burned gas of combustion. But gasification, besides the heat, we will get a combustible gas which can be used later. So most gasification, we will get a combustible mixture of gas which is known as syngas, or some case we call it as producer gas also. So that syngas is a product of gasification. But in combustion, we will not get any syngas. Our gas is already burned. It will be carbon dioxide and water vapor. And only we will get heat. But here, gasification, we will get heat plus a combustible mixture of gas. And pyrolysis, we will get all the three phases. That is, we will get a solid biochar. We will get some bio oil. And we will also get the combustible gas. So pyrolysis, we will get all the three. Biochar will be obtained, bio oil will be obtained, and combustible gas also we obtain. And what are the principal component of gas? That is output gas we are getting. We know that combustion, it is carbon dioxide and water vapor. Because it is complete combustion, all the carbon in the biomass will be converted to carbon dioxide, and all the hydrogen will be converted to water vapor. But in gasification, the main product will be carbon monoxide and hydrogen, because we are providing only very less oxidant. Carbon dioxide also will be there, but our main product will be carbon monoxide and hydrogen. And pyrolysis also, this will be the same. We are providing very few oxygen or limited and nil oxygen. So we will get only carbon monoxide and hydrogen. So this is the comparison of these three phases, these three routes of energy production, that is thermochemical conversion. And we will study in the upcoming modules and chapters in detail about these three. And if your combustion is also known as incineration, if you are converting a waste into heat, we may call it as an incineration also. Now we have the biological conversion. In this, the most important one is the anaerobic digestion. We know that anaerobic digestion, and it is also known as biomethanation. What is anaerobic digestion? It consists of a series of biological processes in which the microorganisms break down the biodegradable material in the absence of oxygen. So these are carried out with the help of bacteria. And another thing, this in the absence of oxygen, that is why it is known as anaerobic. And it is a complex process. And what is the temperature? Temperature is also very low, not that much high in thermochemical conversion normally, but slightly higher than our room temperature. You know, we have two range of temperature for two types of bacteria. That is mesophilic bacteria. They use the temperature range of around 37 to 40 degree. And thermophilic bacteria use a slightly higher temperature, that is 50 to 60 degree. So this is the normal range of temperature we will prefer in anaerobic digesters. And we know the main product of this process is biogas. So this is a block diagram of that. So what are the different, we can convert anaerobic digestion, biomass, mainly energy crops, we can use animal waste, an important input, industrial waste, municipal solid waste is very very important, and food waste like restaurants and sludge from wastewater treatment, all these can be used as an input for anaerobic digester, and this convert mainly into biogas. And other than this we will get some compost, some slurry, that is the biofertilizer, we can use it for plants. Hydrogen also we may get, but our main product is biogas. Now what is biogas, that is our question. So we can see biogas is a combustible mixture of gas which mainly consists of methane. So in biogas the main constituent is methane, and it will be around 50 to 75% depending upon the reactor and residence time, etc. And other than this we have some carbon dioxide also, normally it will be some 25 to 50%. So this is the main constituent of biogas, methane and carbon dioxide. And other than this we will have some nitrogen also. So mainly if it is of animal waste, this nitrogen content will be high, that is 0 to 10% will be there. And hydrogen sulfide, another important, which gives the foul smell to the biogas. Hydrogen sulfide also will be present from 0 to 3%. Again it will be high for animal waste but very less for plant waste, and few hydrogen also. So that is the important process, that is biomethanation. We will get biogas as the main product, and it is carried out with the help of microorganisms. We have two microorganisms, mesophilic bacteria and thermophilic bacteria, and its temperature is 37 to around 60 degree, we can say both, and biogas we will be obtained. So this is the overall. And this, what is the residence time, so how much time it will take for conversion of this into biogas, that is known as the residence time, and that will depend on the substrate and temperature of the system. So we will this also we will study in detail later. Now another biological force also is there, that is the fermentation. Here we are not using any bacteria, but you are using enzymatic conversion of carbohydrates, especially into smaller simpler compounds like ethanol or ethyl alcohol. And this does not need to be in anaerobic condition, so it's also work in anaerobic condition, but it does not need to be in anaerobic condition always. And yeast is used mainly for this fermentation. We will be using yeast, and it can be used in the presence of oxygen also. And this is the reaction. So fermentation means we are converting carbohydrate, that is C6H12O6, that is a carbohydrate. We are adding yeast, and after some time we converted into mainly ethanol and carbon dioxide. So that is the fermentation. So what will be, how will you compare this thermochemical conversion and biological conversion? This is an important comparison. So suppose if you have a biomass, which route you can go? So you can either go in thermochemical conversion, that is gasification or combustion, or you can go with biological conversion. So how will you select which route you are going to put for energy conversion, so that you can answer at the end of this comparison? So the first point is, we know that it is thermochemical conversion is high temperature process. We give the temperature range, we can see 800 to 1200 degree for gasification and combustion, and pyrolysis is slightly less. But biological conversion is normally at some 30 to 60 degree, and it uses microbes or enzymes for the conversion of biomass. And the important thing is, we already know what is the lignocellulosic composition of a biomass. So every biomass will have some lignin, will have some hemicellulose, cellulose, extractives, etc. And the important thing is the thermochemical conversion, which does not sensitive to lignocellulosic composition of biomass. That is the most important advantage of thermochemical conversion. It does not depend on how much lignin is there. We have already studied lignin is most difficult to decompose by biological process. So the biological conversion, if you have to apply the biological conversion, the lignin content should be less than 10%. That is the important point we have to note. So that is why in our home, etc., we have seen so many news recently that the biogas plants installed in our municipalities, in our household, etc., are not working. So this is the main reason, because the biological conversion will not work for biomass where lignin content is high. So for example, you have the crust of egg and this onion leaves. So these are not digestible by the bacteria, and if you are putting all these in the biogas digester, the bacteria will stop working and the entire system will stop. So that we must be very careful while selecting which biomass or which waste we are to put in this anaerobic digester or for biological conversion, because this point we have to remember, that is, if lignin content is high, it will take very much time for bacteria to digest, or some case it will stop also. But thermochemical conversion does not matter. For example, coconut shell, we can see the coconut shell is a particular biomass in which lignin content is very high, and we can easily gasify coconut shell or combust coconut shell. But if this coconut shell is put into an anaerobic digester, it will slow down the working of bacteria. So that is the important point we have to note. But the green color is given as an advantage of that particular route, while the red color is given as the disadvantage of that particular route for easy understanding. So already we have one advantage for thermochemical conversion, that is, it is not sensitive to lignocellulosic composition. But here you can see another disadvantage of thermochemical conversion is the biomass must be reasonably dry. Almost less than 30% moisture content is required. But here in biological conversion, it will be, we can use very high moisture content biomass like 70 to 90%. So that is the important advantage of this biological conversion. It should not be very dry, but in gasification and combustion it should be dry at least 30%, or in mostly we will prefer less than 10% moisture. So if the biomass is having 30% moisture, we will sun dry for a few days so that it will come down to less than 10%, and we can easily gasify it. But if it is higher than 30%, we will not preferred for thermochemical conversion. That is why the municipal solid waste or food waste, etc., are not suitable for gasification or combustion. So they will be better suited for biological conversion, because the water content is 70 to 90%. So that is the advantage of biological conversion. And another advantage of thermochemical conversion is the residence time is very few. We know that a few seconds to few hours only. So if you put coconut shell in a gasifier, within some 2 to 3 hours we are getting the output gas. But what about biological conversion? We know that the residence time is around 1 week to 2 weeks, or in some other case it will be 1 month also. So that much time is required for converting a biomass into biogas, our energy production. It will be very much long. The biological route will take minimum of 1 or 2 weeks to 1 month. So that is another advantage of thermochemical conversion. Therefore it will be having high rate of productivity, but biological conversion will have a very low rate of productivity. And another advantage of thermochemical conversion is there is no effect in ambient conditions. So whatever be the ambient temperature, whatever be the ambient pressure, etc., humidity, etc., it will not affect the thermochemical conversion, because already we are heating and liberating heat very high temperature. It does not depend that much on atmospheric condition. But these biological methods are very much susceptible to atmospheric condition. That is why in winter season, when the temperature goes below 30 degree, that is around 20 degree, etc., the bacteria will have a problem, because already we have studied the range of thermophilic and mesophilic bacteria. They are around 34 to 60 in that range. So when the ambient temperature goes below 30 degree, below 20 degree, etc., in winter, it will affect the anaerobic digesters. That is another important advantage of thermochemical conversion. And this is also another advantage. We are getting multiple products. For example, in pyrolysis, we are getting biochar, we are getting combustible gas, we are getting bio oil. Similarly, gasification also, we are getting a heat plus combustible gas. But in this biological conversion, we have only one or two products. That is mainly biogas. Anaerobic digestion, we are only getting biogas plus some slurry, which is used as biofertilizers. So it is only one or two products are there. But another disadvantage of thermochemical conversion is mainly cooling and cleaning is required, because we know it is high temperature process and the carbon particles are generated. We have to use some cyclone separator, some scrubber, etc. We have already seen in the gasifier. These are required, and cooling is also required before finally we are letting the gas through the outlet pipe. But in biological conversion, there is no need of cooling. It is a low temperature process, and cleaning also not much required. Unless it is having very high hydrogen sulfide content, there is no such cleaning is required, because already it will have only methane and carbon dioxide. But this thermochemical conversion, we have these carbon particles are generated. We have to use some cleaning techniques like cyclone separator, scrubbing, etc. And another disadvantage of thermochemical conversion is the material of the reactor and the accessories just to withstand high temperature. So it should be made of steel, ceramics, etc. And it will be costlier. We know that if a gasifier, you want to purchase a gasifier of minimum capacity, it will be more than 5 lakh or more than that much price is there, because it is to be made of material which will withstand high temperature. But on the other hand, this biological conversion process are a low temperature process, so this cost is comparatively less. The installment cost and the purchase cost is less, because the material of anaerobic digester will be mostly some PVC or some concrete, etc. So that was the comparison of biological and thermochemical conversion. And we have another chemical conversion process. Already we have briefly discussed thermochemical conversion, biological conversion. And third choice is we have some chemical conversion process. In that, the most important one is the trans-esterification. So what is trans-esterification? It is used for the production of biodiesel. In this, an alcohol such as methanol or ethanol reacts with triglyceride oils contained in the plant oils or animal fats or recycled grease, etc., to form fatty acid, alkyl ester and glycerin. So it is these alkyl esters are known as biodiesel. So this is trans-esterification. So trans-esterification, we require some oil. So either it will be plant oil like coconut oil, palm oil, or some other used oil, anything, or it can be oil from an animal fat also, like chicken waste, beef tallow. So from all these we can produce oil. So this is reacted with an alcohol, that is mostly methyl alcohol or methanol, and our product will be glycerin and alkyl ester, and this alkyl ester is known as biodiesel. So if you separate glycerin, you will get biodiesel. But this reaction requires a heat, and a catalyst, a base catalyst also requires, such as sodium hydroxide or potassium hydroxide. So this is the reaction. We can see a plant oil is there, the first reactant. It's reacting with methanol, 3 moles of methanol, with the presence of some catalyst like sodium hydroxide or potassium hydroxide. Two products are there. First one is a acid methyl ester, that is the biodiesel, and glycerin or glycerol, so that we can separate and we can use this biodiesel in diesel engine mixed with diesel. So you might have heard B10, B20. So that is the we cannot use completely biodiesel in an engine because the properties of biodiesel and diesel are slightly different. So you can use mixing with diesel. So B10 means we are used 10% biodiesel and 90% diesel. B20 means we are using 20% biodiesel and 80% actual diesel. So like that we can use. So this is transesterification, a chemical process. So we are using a chemical reaction for converting our biomass into biodiesel. And finally we have physical conversion process. So physical conversion process, we are not directly generating any energy or any gas, etc., but we are converting our biomass into a more useful form. So mainly it is densification. So what is densification? Densification is the process of increasing the density of biomass. And what is the advantage of increasing the density of biomass? It will give more uniform properties, and energy density also will increase. And what is densification? Densification is actually we will use high pressure, different range of pressure are there for different biomass, and when we apply this high pressure and some binders are used like starch, molasses, etc., there will be an interlocking and additional cohesion of solid particles, and the intermolecular bonds are created in the contact area. And this resulting product from biomass, we call it as a briquette. If it has a diameter greater than 30 mm, we call it as a normally briquette. But if we have less diameter, we call it as a pellet. So this is the figure of that. You might have seen somewhere. First one is a briquette. So diameter is more than 3 centimeter or 30 millimeter. We call it as a briquette. And it is having a less diameter. We call it as pellet. So these are used as input fuel for boilers, and most of the industry also we can use these briquettes and pellets. So what is the main advantage of this method is it reduces the cost of transportation due to increased energy density. Suppose we have some sawdust as our biomass. So if you are using directly this sawdust for some industry, for some boilers, etc., we have to use a very huge cost for transportation because this density of sawdust is very, very less. But on the other hand, if you are using some densification techniques, you are using some process, high pressure process to convert this sawdust into briquettes like this, we can very easily transport a huge quantity to our industries, and this energy density also will be high. It will have more uniform properties, etc. So these are an overview of what are different energy conversion methods that is possible from biomass. And finally we can conclude that, so if you have a particular biomass and you want to decide which method you have to choose, so mainly you have to understand what is the lignin percentage and what is the moisture percentage. Suppose if the lignin percentage is very high, it is not suitable for biological conversion. It will be very much suitable for thermochemical conversion only. And similarly, if the moisture percentage is high, more than 30%, it is not suitable for thermochemical conversion. It is suitable for biological conversion. And if you have some oil that can be made from this biomass, like animal fat or some seeds, etc., it will be better to convert that into biodiesel by transesterification. so that we can use it in IC engines. And another choice is you can convert this biomass if of less density into high density by densification, and you can travel that biomass into a particular industry and use for direct heating. So these are the choice available, and you can decide by comparing all these parameters. So in the coming sessions we will discuss more detail about these each routes. Thank you.